In this video, I would like to address one final topic in the area of composition of functions, and that is decomposing composite functions. This is an important skill to develop for calculus as we begin to look at functions that are nested inside other functions. We can think of those as composite functions. So suppose f composed with g of x is the absolute value of 1 minus x cubed. So we're looking at a composite function here, and we're asked what might f of x and g of x be? What original starting functions would result in this composition? It's helpful to remember that when we're looking for g of x, we are thinking about what's the inside function. And when we are looking to express f of x, we're thinking what is the outside function here? And there may be more than one appropriate choice for f of x and g of x. There often is. So for example, here I might say g of x equals 1 minus x cubed. That's what I see happening on the inside of this absolute value. If I express g of x that way, then f of x is equal to the absolute value of x. And I could even practice this using the composition of functions. F of g of x should equal the absolute value of 1 minus x cubed. However, that's not the only answer. That is one good answer for f of x and g of x. But another student might look at the same expression, same equation, and say, hey, g of x equals simply x cubed. That's what I see happening first to the x value. If we make that choice for g of x, then f of x equals the absolute value of 1 minus x. And again, we could test this using composition of functions. F of g of x, in this case, would equal f of x cubed, which would equal absolute value of 1 minus x cubed. So this is another logical choice for the building blocks, the original functions that made up this composite function. Once again, the choice is up to you. Let's consider one final example. Suppose f composed with g of x is 1 over x squared minus 4. Again, if you're trying to name inside and outside functions, there's more than one logical choice here. So one choice would be to say g of x equals x squared minus 4. That's in the denominator of the larger function. If we make that choice for g of x, then f of x is equivalent to 1 over x. So here's one possible answer. Another possible answer is to say g of x is x squared. That's the very smallest function. That's the smallest thing happening to x. In which case f of x represents everything else. So it's 1 over x minus 4. This is another logical choice for the functions f of x and g of x. So it often may not matter how we decompose composite functions, but recognizing composite functions and being able to express them in their decomposed parts is an essential skill as we go forward into calculus.